seconds. Okay, it is now recording. I'm checking the meeting settings. Is that two people joining at the same time? Oh yeah. And then I know some people like to do spiritual things. They tell them mute, they don't mute. I give up. It's not worth it wasting my energy. I did mute. Who's this person who's unmuting? I'm hearing some background noise. Okay. I almost closed the Teams. It's okay. So, like I said, you're gonna have a lot of homework. There's like around 6, 7 homework assignments you're gonna have to implement. But you get to that on your own time. That's a you problem. Me, I don't have to do homework. So let's start. So I'm gonna open Eclipse. So the difference between a loop, okay, an if statement and loops. A loop runs once, if you remember, right? A loop only does the check once. An if statement, I mean. And then a loop, it does it continuously as long as that condition remains true. So that's the difference. So they're basically the same thing. An if statement and a while loop, if you notice the syntax, they look the same. The only difference is that one runs exactly once, and then the other one runs specific number of times or basically more than once. That's the main difference between them. So I'm gonna open Eclipse. Let's wait for Eclipse to behave. I think I need to get a MacBook. This Windows stuff, I don't know. MacBook just does everything. Everything is good in MacBook. It's fast. You have no issues. Comes to Windows, you see, it's still loading. I don't know what is low. Why is it taking so much time? And my laptop is like 16 gig RAM, so it's not a slow laptop. So yeah, some operating systems are just not that good. So there's Mr. Fowl here. So I'm gonna minimize close this project. Close project, and then I'm gonna create a new project. Like I said, I'm trying to limit to 1 hour, but I'll see. We'll see how it goes, right? We'll see. But I'm gonna try to limit it to an hour because 2 hours is kind of crazy. Because I remember researching about the brain. The brain can only concentrate a maximum of 45 minutes. Anything beyond that, you're just lying to yourself that you're concentrating. The maximum time is 45 minutes. Then if you are built different, then maybe an hour max. So this is chapter 4 to 6. Right? It's not a valid Java identifier. Oh, okay. So I'm gonna use underscores. I didn't know that. I didn't notice. Hmm. That's interesting. I guess you learn a lot. So basically, the way you name your project is exactly you must use a similar technique to where you name to the way you name variables inside Java. That's why when I put a hyphen there, it says an identifier is invalid. It's not a valid Java identifier. I didn't know. I was just doing what the lecturers told us to name it that way. And operating system, it kind of, actually, I forgot to unselect this. Make sure you don't include the module info thing. If you include it, it's not going to run. Then I'm going to create a new class that contains the main method. So public static void main. So I usually, it's very important to tell Java to include the main method. So that's why I'm selecting public static method so that it includes the main method when it creates this class. Then I can select the generate comments so that it generates a little bit of Java doc there. I would have to fill it in, right? So I'm gonna, just to make myself look very professional. So I'm gonna start putting my details here. I'm gonna say at author Vertex Academy. Then I'm going to say add version, which basically describes what the code is about. If it, for you guys, you're usually going to say it's practicals 5 or practical 6, practical 7. For me, I'm going to say it's chapters 4 to 6, right? So these are the chapters we're covering here. So when it comes to if statements, right? If statements, if you remember if statements, like let me make a simple example. So let's say you have who's not unmuted now? I feel like you guys like let me keep quiet. Hey, people they underestimate me. I have a sharp tongue. Piss me off one more time. I dare you. You live to regret it now because now people I feel like they're taking me lightly. When I say mute, I say mute. You can't be that blind. You can't see the mic icon. No, I don't know anyone who's blind here. Unless you can send me a prescription, something, then I can admit that yeah, you are blind to to a certain extent because you get glasses, so you're still not blind. So don't get on my nerves. So I'm gonna create a variable. I'm gonna call it age, right? And then I'm gonna initialize and put a value of 21, just to check if you are legal age to drink, something like that. Should I say it doesn't really matter, but I just want to demonstrate this example. So you have okay, let me put it this. I can put it that way, but it's fine. I'll change it later. So I'm gonna do an if statement to check if your age is greater than or equals. Why am I using equals? Because if you go back to mathematics, when you create ranges or domains, so you define a domain or a range, you either use square brackets or round brackets, right? So I want to check for people who are from 18 years and above to infinity. So it's inclusive. It includes 18. So that's why I'm going to choose greater than or equals to. Greater than or equals to 18. So this basically translates to from 18 to infinity. Then I output I output a response. So I'm going to say system dot out dot print line. Right, then it's going to say you are of wait. Yeah, before I start, I'm moving way too fast. I'm moving to loops, but it's fine. We'll go back to strings. Let's just start with the loops. But I should have started with strings. So you're of legal age, right? Of drinking age. Let me just say of drinking age because we are checking if you're old enough to drink. I'm not sure if the Constitution says 16 or 18. I forgot, but we're just gonna use 18 because different countries have different rules. So this will run once. It does an if to check if this part is true. If this condition, we call this a Boolean condition, right? Or a Boolean expression. Basically, by Boolean expression, it means that it returns a Boolean, which is basically a true or a false. So if this returns a true, because we're expecting a truth value of true in order to execute that statement within the if statement. So if your age is at least 18 years, then you're of drinking age. Then if you run this, it should display your drinking age, right? So there's the output. But what if we want to not do this thing once? We want to do it more than once. That's when we do things like while loops. And there's different types of while loops. You need to understand the different types of while loops that are available. So I know this is a very bad example because I could have chosen a different example, but I just wanted you to see similarities, right, between a while loop and while loops, a for loop, just loops in general, and selection statements or if statements. You see that there's an if there. It's like that, right? A while loop would look like this. So you basically replace the if with the while. So this will be a while loop. But then the difference between these two, right? I'll give you code examples right now. So the difference between these two, this is an if statement, it runs once. So the statements in between the curly braces basically starting from here, stopping there. Those statements, they run exactly once. If with the while loop, it runs as long as this part is true, right? So as long as this is true, while true, it will keep on running. So that's why we always need to make sure the part that's over here, right? We update it so that eventually our loop stops. So we have three different kinds of loops. So I'm going to delete this. We have three different kinds of loops. We have a do while loop, not three, there's four. Yeah, four. So we have a do while loop, then we have a while loop, right? Then we have a for loop. Then we have the last but not least, the for each loop. So we have four different types of loops, basically four different ways to repeat certain code. I don't know if I've explained it yet, but if you're concerned about why do we always use curly braces, what's the whole significance of that? Curly brace, they define something that we call scope. That's what curly braces do. They define scope. How is scope defined? If you didn't know, you can actually use curly braces without anything, right? So you can actually just create curly braces like this and then start create code for that curly brace. So what this curly brace, right? They define what we call scope. This defines the start of the scope. Basically, another way to view it, think of it as a range in mathematics, right? Think of it as like the range. So that's the start of the range. This is where it stops. To stop the scope. So if you happen to declare anything within the curly braces, they are defined within that scope. That means they only belong to that scope. They only belong to these curly braces. So let me make a simple example. I'm going to say int value is equals to 20, right? Simple code, right? I declare the variable there. Then I go after the stop where the scope stops. Then I'm going to do something very spiritual. I'm going to try to output it. So system.out.println value. And then you see that is going to give you an error. It's going to say it's not declared. But in this case, it means the same thing. But Java calls it, or Eclipse refers to it as a value, or that variable named value cannot be resolved to a variable, meaning there's no such variable that's declared. But then you're going to be like, wait, there's the variable. How come it's not picking it up? We have something that we call scope. That's why we always have curly braces almost everywhere that define what we call scope, meaning that thing is contained only within those curly braces. But if I take this system.out and I put it within the curly brace, there's no error. They define scope. But with the scope that you defined, it runs once. I'm really breaking this thing up in such a way that you guys can get to really understand what's going on. So with this scope, it runs once, right? There's multiple ways to work with scope. You can give the scope a name through the means of methods or functions by creating a function. That means when you call the function, you're just implementing this code that's defined for that scope or for that function. Then you can also use while loops, which you see that it's still curly braces, it's still scope. So the only difference is that now this curly brace, right, they define a scope for a while loop. You can also have a scope for a do while, like this here. Then you have a while here, but then I have to put it before the comment. So you're gonna have a while here. That would be a do while, right? So scope is very important. I want you to be familiar with curly braces so that you see that they're not just there for fun. They know what they're doing. What's this now? What's going on now? Okay, let me do this. Let me do that. Okay, cancel. So this defines scope. So now let's talk about the different loops. So if I was to make a diagram, right? Let's do a simple, let me see, let me start with the while loops, right? The while loops are easier to translate to a for loop. So you need to understand the while loop before you can go to a for loop. So if you go to a while loop, right, let's start with the do while. What's the difference between a do while and a while loop? A do while, right, it runs at least once. That's the difference between a do while and a while. A while loop, it runs if the condition is true. That means it might not even run at all. So you need to know which problem you're solving. If your problem that you're solving, it needs you to at least run the code at least once, you need to use a do while loop. If it doesn't really matter, just use a while loop. So let's make code for printing numbers, right? So I'm gonna create a counter, so int count. I'm gonna initialize it to 0. We start counting from 0. Or you can say 1, it's up to you where you want to start counting. Then how do you do the do while? It's called do while. So therefore it's gonna have the keywords do and while, right? So it's gonna have do and while. So hence do while. Then you need to define a scope for that do while loop. And how we mentioned this, how do you define scope for something? You use curly braces. So in Java, I know some of you are used to this syntax of putting the curly braces in a straight line like this. No, it's not allowed. Okay, not necessarily it's not illegal, but it's like, why would you do that? Because Java developers, they don't implement it like this. You need to implement it this way. So you put the opening curly brace on the same line as the do keyword, but then make sure you put a space after do. Don't don't leave it like this. Very untidy. So you need to put a space there. Then after, when you reach the closing curly brace to close the scope, that's when you put in the while. I don't know what's going on here. Okay, my mic is, sometimes it mutes itself. I don't know why it does that. But yeah, now it's not muted. That's weird. I don't know what's going on with Teams. So you're gonna put the while keyword, but then before the while keyword, like I said, you need to make sure your code follows Java, sort of like Java, not necessarily rules, but Java, it does it in what we call the Java way. So you need to put a space right before the while keyword. Then this condition is a condition that's going to return a true or a false. Remember, we talked about the different operators. There's relational, then there's logical. Relational is the ones whereby you have two equal sign to check if one variable is equal to another. You have greater than or equals to, less than or equals to, and so forth. You get the idea. Then we have logical operators, like two ampersands, which just stands for the end in logic, right? Then we have the two pipes, right? These two straight lines, which represents the logical or, right? Then we have the last one, which is exclamation mark, which represents a not or negation. So these are the different operators we're going to use because they return true or false. So I want to count, right? My goal is to count. That's my goal. So that means I need to have some mechanisms or some way to count inside the loop. How do I do that? It's up to you where you want to start. If you want to start at 0 or 1, it's different in whatever your case is. So I want to start at 0. So that means before I do anything, I'm going to say sys out, then I'm going to press Control backspace to autofill for me. Then there's the system.out.println. I want to print my count. Then what condition am I going to check? The condition is basically when should the loop become false? But then at the same time, it's like, while this condition is true. So that means you put in a specific condition, right? That's where that condition you put in, it will allow the loop to eventually become false, right? Or as long as that condition is true, whatever way you want to picture it. So I'm gonna say, as long as my count variable is less than 11, it's up to you how you structure it. Basically, I want to count from 0 to 10. You could just say it's less than or equals to 10. That's still okay. Like I said, we think in different ways. It's up to you in whatever way you want to write it. I'm going to say while count is less than 11. Remember, we talked about relational operators. These operators, they compare, or we do a comparison, then they return a true or false. So it's gonna see return true. If it is true, then it executes what's inside there. Then if it gets to false, that means the loop exits, it stops. Because the while loops, they continue to execute while the condition is true. But then we have this is what we call in our loops, right? This is what we call the initialization statement. That's the statement to initialize our variable. In this case, if it's used in a loop, I'm gonna use that word. I'm gonna just use it in such a way that you shouldn't be using it. But if a variable is used in a loop, we can call it a loop variable, but it's not really a loop. Loop variables, it's only variables that exist within the loop. But in a way, you can say that this is a loop. This is our loop variable. So this is the initialization part. And you see that this initialization part, it happens so how many times? Once. That's very important to understand. It happens once. Then we have our loop. This is our code, right? This is the code part between the curly braces. Then we have our Boolean expression. So this will be the Boolean expression. Basically, an expression that gives us back a Boolean or a true or false. But if you notice something, let's read the loop. This is how the loop is gonna run. It's gonna say do, meaning do this, do whatever is inside the curly braces, right? So that means that means it runs at least once. Then it checks after running whether it should continue or not. So that means it runs at least once. So in this case, I'm going to tell it to do what? An output statement, and output the current value of count. Then it goes to the condition, is count still less than 11? If the answer is yes, it goes back up to the top there. Then it does the thing again. But then in this case, I want you to notice something. We're going to have what we call a special case of a loop. We're going to have what we call an infinite loop, meaning that it never stops. Because it's going to keep outputting, but we're not actually updating count. That means count will never reach the point whereby it's greater or equals to 11. It will always be the same number. That means it's going to be an infinite loop. I would advise doing this. Don't try to run when you have an infinite loop, but I'm going to run it and show you. You see, it's still running. As you see this red thing, it shows you that it's still running. So I'm going to, yeah, you see, I told you guys, I don't do this. Apparently Eclipse doesn't allow you to stop. Let me end task. Do you see the dangers of infinite loops? I'm sure you can see it now. It literally crashed my Eclipse. Like I said, don't do that. Really understand your loops. Make sure, basically what we're missing something that we call an update statement, which basically means that we're going to update the variable so that eventually it reaches the stopping point. So we don't have one here. That's why it was having an infinite loop. We need to have a update statement. So it makes sure the update statement is between the curly braces. So I'm going to put the update statement here and say count is equals to count plus 1. So what this means is that go into the box with the label count, get what's inside that box, add 1 to it, then take that result and store it back into the same box. So that means in a way, I'm actually incrementing the variable itself. But remember, there's ways to abbreviate this, but I'm not going to abbreviate that because it seems like not all of you are very confident with writing code and abbreviations and stuff. So yeah, so it's okay. So it doesn't really matter, but we see that our output eventually stops, right? You see, it doesn't show the red square. If it's still red, that means it's still running. In this case, it terminated. It ran quickly and then it stopped. So these are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then this 20, just remember that 20 is this part over here. That's that 20. So our loop does now work, right? Then how can we translate this to a while loop, right? How can you translate this to a while loop? So it's almost similar. The only difference is that you don't have a do keyword and it's sort of like flipped. You see, you flip it, right? You take this and you put it right there. And then there's no do keyword. So that's basically while loop. So you're going to say while sum condition that's here, and then that's it. But then the difference, right, they might look like it's similar, but there's a slight difference. This runs at least once. So let me show you, let me prove it to you that it runs at least once. Let me say count is 12. 12 is not less than 11, right? So it should stop, but you'll see something surprising. It's gonna output one number, which is 0. Okay, it shouldn't, oh, 12 because count is 12, my bad. It's gonna output 12 because count is 12. Then it's gonna compare. Okay, it's gonna increment count by 1, which count becomes 13. Then it's gonna compare 13 with 11. 13 is not less than 11, so the loop stops. But you saw that it ran at least once, but it shouldn't even be running at least once. But in this case, it is running, which is not what you intended to do. So we need to use a while loop for that. So I'm going to say while count is less than 11. I'm going to write the exact same. I'm going to use the exact same example to show you different loops. Remember what I talked about, a while loop, and especially a while loop and the for loop, even a for each loop to a certain extent. Not necessarily for each loop, but for loop. Let's just look at while loop and for loop. They are similar to an if statement. If you've noticed, the only difference is the keyword. So here usually we put if, right? But then if with an if statement it runs once. Here I wanted to run it for specific more than once for a specific number of times. And while loops, you use it when you don't know how many times you're going to run. In this case, I know how many times I'm going to run. So this is actually a bad example in terms of understanding code. It's a bad example to use a while loop like this. You should have used the for loop because you know you're counting, you know exactly the stopping point and the starting point. So a for loop is preferable, but you can use a while loop. That's still allowed. So the way a while loops works, just like an if statement, you say while or if, is this condition true? If it is, execute. Then it reaches here, then it goes back to the top, it checks, is this condition still true? If the condition, as long as the condition holds true, it'll execute. But do you notice the difference? I started by saying, is the condition true? Basically, I start by asking the question. That means this loop might not even run. Unlike a do while loop, which just says, do this, then you check if this condition is true. So it's different. A do while loop runs once, a while loop it runs at least once. A while loop can run 0 or more times. That means it can actually not even run once. In this case, you see that it's not gonna run. Then the code is the same. Okay, this, like I said, this is called an update statement because it helps us to update this loop variable so that this condition eventually becomes false, so that we eventually exit the loop. You saw the dangers of having an infinite loop, right? So be careful of that. Don't have infinite loops. So we have this here, and then I'm going to just copy paste that. Then you see that I don't like doing this, but it's fine. Let me just put comments. I'll just put comments here. You can just comment it out if you want to test it out. So you see that it only shows 20, which is this part over here. That means not even one value is displayed here because that's how a while loop works. It looks at the condition first. It tests, is count less than 11? So basically what this does, it goes to that box with the label count. It takes the value that's inside, of which the value that's inside the box is 12. So it's going to say 12, and then it checks, is 12 less than 11? The answer is no, so false. So this will be false. So that means this won't even run. So that's the difference between a do while loop and a while loop. A do while loop runs at least once. A while loop it might not even run even once. So basically, while loop is 0 to infinity times. That's how many times it can run. A do while loop, it's 1 to infinity because it can run at least once. It's always at least once. So it's always 1 to infinity, always, the do while loop. While loop, it's always 0 to infinity because it might not even run at all. Basically, runs 0 times. So I will demonstrate, I'll put diagrams. Let me see if I should do that. But the thing is, the session ends up being very long. But let me try to quickly demonstrate that. So I'm going to have draw.io. Okay, I can just I can just use this. That's gonna take too much time. Then here I was explaining arrays in C++. So let me delete this. So if you still remember first year, I doubt you do, but you should. If you don't, you should get yourself some omega-3 to help you improve your memory. So you have these diagrams that you're making in first semester last year or last of last year. I don't know, but it should be last year for everyone. I don't know. So you know, sometimes you can't register modules, but whenever you did first year ComSci, the first year ComSci, you did these diagrams first semester. You had when you had loops and what and if statements, you'd make these diagrams, right? Then this diagram would have a question in here, right? For example, is count less than 11? That's the question that it asks. Then if it is true, we have a true branch, and then if it's false, we have a false branch. So let's see what should happen when it's false, what should happen when it's true. So let's analyze the while loop, right? Let's just look at the while loop. The condition is this. That's the question we're asking. Then if it is true, it executes these 2 lines of statements, right? These 2 lines of statements or code. So let me do that. So if it's true, let me put text there. So if it's true, it's going to damn, that's weird. Hey, let me quickly do this. Yeah, you need to understand the operating systems very well. So what's happening is that Eclipse, the way it works, when you copy and you transfer, it's different from copying from Notepad. You see, now it's working. Yeah, you need to understand the operating systems. It's really such a drag, but yeah. So if it's true, we go to the side, right? So I'm gonna put in an arrow there. So if it's true, we go that side. So this will be when it's true, right? So true, it goes that side. And then when it's false, let me see. When it becomes false, yeah. So I can do it this way. And then there should be some black circle here to show the end of the program. But let's not overthink it. I'll just put a small circle like this. Just know this means that we go to the end of the program, right? The program reaches its end. So I'm going to put in a line there like this. This is when it's false. So when it's false, the program stops. Just imagine we only have that one loop. So false, that's when it's false. Then it's going to just simply exit the app or exit right from running. So this is a while loop. If I leave it like this would actually become what I call an if statement. But this is not an if statement. I'm demonstrating a while loop. So what I'm going to do is the arrows are not done. It's gonna check if this condition is true. If it is true, we do this. We execute these 2 lines of code. Then it goes back to the top. So it's gonna go back up here like this. I need this arrow here. Then it's gonna go back and ask the same question again. Is it true? Execute. Goes back up, ask the same question again. Is it true? You see, I feel like you can see the loop now. It's gonna go round and round and round, right? Then eventually count is gonna, because we are incrementing count. Do you notice here we are updating count by 1. Eventually count will be a number that's bigger than 11. So this condition will become false eventually. When it becomes false, there's the false branch. It goes this side and then we stop running it. Basically, we exit the loop. So I hope this diagram can now help you picture the loops and how they work. It's actually similar. Yeah, they're basically similar. The thing is, some loops, they hide details. For example, for each loop, it hides a lot of details, but it actually works exactly the same way. Then we have the for loop. So the for loop, right? Let me do this. Copy this and put it down there. And then I'm just gonna make it 0. Right, so I'm going to basically do the same thing here to show you the difference between a while loop and a for loop. I'm gonna repeat that code, but then using a for loop. So what's the difference between a while loop and a for loop? A for loop is used when you know exactly how many things you're going to count or how many times you're going to count. A while loop is mainly used for when you don't know how many times, like the exact number. For example, you're reading a file. So in C++, you can use, for example, the getLine method. So you say while getLine, basically you just like while scanner dot has next line. They're similar functions. So you can say while scanner dot has next line, you check that if it has a next line, because you don't know if it has. You also don't know how many lines are there in the file. So that's when a while loop is very useful, because you don't know how many times, but you know eventually it's going to reach a false state. Basically, the loop is going to exit at some point, but we don't know when it's going to exit and how many times it's going to run. With the for loop, we know the exact number. So, for example, when you're counting, that's why I said the loop that I'm using is wrong. You should have used the while loop, the for loop, because the for loop is useful when you're counting, because you know exactly when you're stopping, how many numbers you're printing, and so forth. So now I'm going to say for. I want you to notice something very similar about these things. This is the for loop, but you see, it's like I just simply changed the while to for. That's the only thing I did. Then a while loop has a for loop has a lot of things. There's a lot of syntax, different ways to use a for loop. You can make an infinite loop, right? By just putting like this. It's weird, right? I know, but yeah, like I said, there's a lot of syntaxes. We're gonna talk about the different variations of them, right? So let me put comments here so that you know where each code goes. So this is the update statement. This is our Boolean expression, right? So this is the syntax for a for loop. You use the for keyword, right? Then you put in your round brackets. Then here you're going to specify the different things. Pay attention, whatever I type here is going to be related to the comments. That's why I'm putting the comments so that you can understand how these things are similar. So here, this is the initialization part. So this is all all your initialization statements go. Then here is the Boolean expression, right? Basically the question that will return a true or false. Then this is the update part. So this is basically how the syntax of a for loop is. So that's why I was putting those comments there, so that you understand what I'm going to do now. Look at the initialization code. It's this part, right? So that means don't copy the semicolon because we already have it there. And we have it there. Don't forget the semicolons. They are very important. You forget them, crash. So semicolons are very important. So I'm going to put the initialization statement there. There it is, right? So I would obviously have to comment this out, right? I would have to comment that out. Then you have a Boolean expression, basically a question that's going to return a true or false, which is basically checking if count is less than 11. Then we need to update count, or else we're going to have what we call an infinite loop. So here is going to be count is equals to count plus 1, but then you can abbreviate that to just count plus plus. So I'm just going to abbreviate that to count plus plus, this update statement. It actually means exactly the same thing. So you can write it in 3 ways. You can say count is equals to count plus 1, or you can say count plus equals 1, or you can say count plus plus, or you can say plus plus count. There's a lot of ways to write the same thing, but just know there's slight variations. They're slightly different, all of them. Okay, not all of them per se. These two are exactly the same. These operate in a special way, special case. So I'm going to have the for loop there counting, then I'm going to have these two statements. But remember, update is now here. So that means I don't need the update inside of the curly braces. I just need other statements. So I just need this statement, because the update statement goes there in my loop, in my for loop. Then I'll get the exact same output. 0, 1, 2 to 10, and then that 20 when you're describing scope down there, that's that 20. So the loop works exactly the same way. But then you just need to notice the similarities, the difference. So basically the for loop is kind of like, it is a short syntax in a way, because you can put it in one line, the initialization, Boolean expression, and update statements. You can put it in one line. Just like here, we did it, right? We put it in one line. That's how the for loop is. But it works exactly the same way. You see exactly this diagram. It does the exact same thing. So this is how the loop works, right? Remember, we talked about the initialization statement. This runs exactly once. Then it's going to initialize it. This runs once. And then it's going to check this condition here, right? It works exactly like a while loop. It checks before it runs the code. So it's like a while loop. The for loop is like a while loop, similar to a while loop. So it's going to check here. If it's true, then it runs. Then it reaches this part. Then it goes back to the top here to the update statement. Then it updates counter, just like it was doing here. Because here, remember, it will check the condition, then execute, then you execute the update statement, then reach here, then goes back to the condition. It's the exact same thing. So it's going to start here. This runs once. Basically, this is done once. We'll never reach to the loop will never go back to the statement. That's how I was explaining the initialization part, that you see that it runs exactly once, so that you understand the for loop. Then it checks the condition. Is count less than 11? If it is, run the code. Then it goes back up here to increment counter. Then it checks the new value of counter. Is it still less than 11? If it is, execute. Then it goes back up, counter. Is it still less than 11? Execute. Goes back up, counter. Is it still less than 11? Remember, I told you this runs once, so it will never go back here. But then I want you to notice something. The count variable, right? This is the actual real definition of a loop variable. This is what we call a loop variable because it only exists within this loop. The moment you go outside of this loop, crash. So I'm gonna paste it here, right? And then you see that it's gonna say it cannot be resolved to a variable. Basically, it doesn't know that thing as a variable. It doesn't exist because it belongs to that loop. That I want you to listen to the terminology I'm gonna use. That variable belongs to the loop. Therefore, it's a loop variable. That's why it's called a loop variable because it belongs only to that loop. But like I said, loops are very flexible, right? You can do this. It's allowed. You can omit the initialization part, but then make sure you declare it outside and then semicolon there. It's weird, I know. And if you wanted to, you can omit this update statement. Maybe you want to put it here. I don't know why you do that. Maybe you want to put it there. Basically, you see, I'm sure you're starting to see that this now looks similar to a while loop, but it's ugly. It's very ugly. It's gonna confuse you if you don't know what you're doing. But let me show you that it runs exactly the same way. You see, same output. So all three of these options they are optional. You can omit even all three. You can leave it. Like you can literally do this. Leave all three, but then you're gonna get what we call an infinite loop. And you know what it does to Eclipse. Eclipse stops working, it jams. So I'm gonna put back everything to the way it was. So there's my for loop. Then a for each loop, right? A for each loop is useful when you're explaining strings. So now I think it's time to explain strings. So I'm gonna explain strings, then I'm gonna go to for each loop. So before we go to the strings, so let me just do this. So the for each loop, right, is you're gonna have one variable here that you're gonna declare. It's gonna store one thing at a time from this collection. And then this collection can be an array. Most likely it's gonna be an array. Yeah, most likely it's gonna be an array. Or if you know, if you're an avid reader, you think about things like hash maps and things like that, but not to worry about that. Just view it in terms of collection, basically multiple values. Then those multiple values, right, they'll be stored one at a time into this variable. That's basically for each loop. It's a way for us to keep track of one value from a collection at a time. Then we can either manipulate it or whatever you want to do, but then just know that value that you get here is going to be a copy. You're going to only get copies. So if you go here and you try to change that variable and say, maybe I want to change it to 100, it doesn't mean that you've actually changed it permanently. The changes they only take effect within this within the scope of this for each loop. Basically within those curly braces. You leave this for each loop. At that position in the array, that variable goes back to its normal value. So this would be the syntax of a for loop. But then remember, you need to also put in the data type here. Then this will be the variable name. And then this will be the name of that variable that is a collection of those things. Whatever those things are. In this case, can be an array of integers, an array of doubles. You can pass the name of the array there, just the name. You only pass the name. Don't be doing spiritual things. I know you guys, you like doing spiritual things. Maybe you want to say marks and then you put in like this. Don't be doing spiritual things. You just only put in the name of the array. Java knows. So don't do spiritual things. So let's talk about the topic that's very important that I like to discuss a lot. Strings, right? So remember we talked about extensively, we did an introduction to programming, an extensive revision, right, on that. Talk about CPUs, what main memory, which is RAM. We talked about all of that. So we also talked about bits and bytes, right? Basically the native language of the computer, which is basically the mother tongue of the computer. It speaks zeros and ones, right? If it speaks zeros and ones like this, how would a computer represent the letters? Basically, how am I able to see this word here, language settings? How am I able to read that if the computer primarily speaks in zeros and ones? We are able to do that because of something that we call an encoding scheme. Basically, an encoding scheme, you can think of it as like a mathematical formula. It's like view the word scheme as like formula, an encoding formula. The simple formula is that the encoding scheme, right? It's a simple formula. It states that each letter, or letter is not the right word. Let's say each symbol. No, symbol is still not right. Let's say each character, because you'll understand why I'm doing that. You're gonna say each character. Each character is. Let me not say. How do I phrase it? Each character has a numerical representation. Yeah, I'm using proper English here. Basically, I'm putting it in a fancy way to just basically say that each letter or each character, it has an integer to represent it in a computer. That's basically what I'm saying there. So each character is a numerical representation in a computer. And we have two ways of representing characters, right? Two ways. We have one way which is called ASCII, which is hopefully I can remember, the American Standard, standard what? I don't know, Institute for American Standard. Yeah, American Standard and Code for information interchange. I think something like that. So that's the ASCII, right? So it's like a formula. Basically, it's a table whereby each symbol or each character its integer is listed there. That's basically ASCII. Because like I said, a computer primarily speaks in zeros and ones, meaning its language is numbers. Imagine if me and you were communicating and let's say I want to say, hello, how are you? I say 35, 32, 10. Me and you understand each other because we speak numbers, right? So that's like a computer. That's how it is. So that's why they had to create a table called ASCII to represent all the all the characters or symbols. But then ASCII, if you check ASCII, it's a history, right? It's very limited. It only represents the characters on your keyboard. You see those characters on your keyboard, all of them, right? All of them, they're stored inside ASCII. But what if I wanna represent I want to store the characters in the Espanol language, right, or French. There's special symbols, right? So that's when developers were like, oh, those creators who manage ASCII, right? They came up with a code, right, which is called Unicode, or a different table. Basically, they extended this table and added more and came up with a bigger one. This one even includes emojis. Do you know that you can print an emoji inside Eclipse? You didn't know? Yeah. Now you know. So you have to find the Unicode, which is the integer number to represent that emoji. Or you can even say hello world in Chinese. You can make Eclipse. Eclipse is this terminal for Eclipse, right? It's configured to work with Java. So you can print emojis here. You can print Chinese, French, you can print it there. So it uses what I call Unicode. For the uni in Unicode just means universal, meaning the whole world, right? It doesn't matter which country you come from. So that's Unicode. ASCII code had around 128 characters, right? So that's why if you look at the char data type inside C++, this is the numbers that it used, right? Yeah, its maximum is 127, right? But in total, it's what it represents 128 characters. Then Unicode, it represents quite a lot, like quite a lot. I think right now there's like I think it's 1 billion, right? It's 1 billion or 1 million, somewhere there. And we only have used, I think so far 60 something thousand of that 1 million letters, right? So Unicode is big. So it will take years before they run out of numbers to represent each letter, right? Before they have to extend it even more. So I think it's like around 1 million um, characters that are there. But then for Java, it uses the older Unicode, right? Java. You can. So, you have to do your research extensively, but probably you can to make Java represent even more. But Java only represents the old Unicode, right? Which is like the very first Unicode. It represented numbers. It had led characters starting from the number 0 up to 65,535, if I'm not mistaken, or 536, somewhere there. Of which this range is actually the range for the data type char inside Java, because Java supports Unicode. It doesn't just support, it doesn't only support ASCII code, it supports Unicode, meaning you can even print emojis inside Java through the char data type. So this is the range for the char data type. Why is that? Why is that the range? Because that was the range back then for Unicode, and Java stores chars or characters in Unicode. So therefore, this obviously would be the range for it. Then this would be what let me see, space. If I'm not mistaken, the 32 number represents space, and then 10, the integer 10 represents the new line character. Yeah, or they call it line feed, right? It's called line feed. So let me show you the ASCII table. You can Google Unicode, that's fine, but I'm just going to show you ASCII. So ASCII table. Then I'm gonna show you the ASCII table. So I typically use this. So you can see here, right? So you need to look at the number system. This is DEC for decimal. So if you are looking for that symbol or a character, I call it characters, but you can call it symbol. It's up to you. These are all the characters. There's line feed, right? LF, which stands for a new line, right? It's actually the number 10. So let me show you. Let's do it in Java, right? Let me not be a person of words. Let me be a person of action. So I'm going to say char, then I'm going to call it new line, and then I'm going to initialize it to 10. Remember, like what we talked about, each symbol or each character, it is an integer representation. So that's why Java allows you to put an integer into a char. Then Java will translate it to its specific symbol. So if I do this and well, you won't see it because remember, a new line character is an empty space. So there'll be nothing on the output, right? But let me show you that it does actually work. It prints. So I'm going to say new line. The thing is, a new line is an empty space. You see, empty space. So basically, it's a white space character, meaning they call it white space because if you were to put it on a white piece of paper, you wouldn't see it. That's why they call it white space characters. Because as you can see, I can't see it, right? But it's there. If you wanted to store other symbols, let's store a symbol that we can see, right? Let's say and you wanted to store symbol end, its number or its what's that code? What's that word for it? I forgot the right term for it, but I think they call it code. This integer number, I think it's the right term for it. It's called code, yeah. So its code is 38, right? So the ASCII character is end, its decimal is 38. So I'm gonna go back here, then I'm gonna change this to 38. So on my output, I should see an end. There it is over here, an ampersand. So I didn't lie. There is each letter or each symbol is represented with an integer. Why an integer? You might ask yourself why. Because remember we talked about binary, that everything is represented binary. We use integer because you can remember if you remember ComSci, yeah, 1A again. You had semester test one, you asked to convert between the different bases or different numbering systems. So convert from hex to dec, from dec to hex, from dec to oct, all those things, right? So that's why they chose integers to represent each character to be represented by an integer, so that when it's translated or stored or translated, let me just say translated or translated to machine language or the native language of the computer, it will be you can convert the integer to binary. That's why they used integers. They could have used octal, that's fine, any number. Before I continue, you see this number over here, binary. Octal, let me think about it. Octal, yeah. Octal starts with in Java, octal starts with 0. And then hex starts with what? I forgot these things. Yes, I remember reading this thing. I'm too lazy to reread the textbook, but I'm gonna give you a few tips here. You can, if you remember when we talked about literals, right? When we talk about literals, we mean the actual values. For example, 38. 38 is a literal. What is 38? It's an integer and it's a literal. So therefore it's an integer literal. By integer literal, right? Try to use common sense. Like I said, if you understand English, you won't struggle with anything. Integer literal, it just means it's literally an integer. That's literally what it means. Hence integer literal. This is literally an integer, right? But you can't say new line is literally an integer. No, it's a variable. It's not a number. This is not a number. This is words. So that's why they use the word literal. You have string literal, you have char literal, you get the point. So there's different ways you can represent literals, right? You can store binary, right, by putting a prefix of 0b, then followed by the binary number. So this is for storing a binary number. This will be a literal for a binary number. Then if the number begins with a 0, that represents octal, right? And then if I'm not mistaken, yeah, I remember it's all x, 0x. If the number begins with 0x, then this means it's a hexadecimal. And then if it's just a number, it's no more, then it's dec. By default, it's dec, which is decimal. So you could technically, if you wanted to, I don't know why you want to do that, make your life difficult, but it's good to practice, I guess. So let's use octal. The octal value is 46, right? So I'm going to go back here, change this to octal 46. But if I leave it like this isn't decimal. This is incorrect. So I have to put a prefix here, which is 0. So in Java, it says, oh, this is an octal value of 46. Then it's going to translate it to decimal, to integer, blah, 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 all those things. You see, still works, right? Because I have a deep understanding of what I'm doing. I wouldn't know all of these things if I didn't read the textbook. Go read the textbook. Then if you wanted to use the hexadecimal number instead, you can do that. The hexadecimal number is 26. But then just know you're going to prefix it with 0x. 0x, 26. Which just means 38. Which just means ampersand. So yeah, there's many ways to do that. So let's continue talking about the word. Yeah, and there's a lot to explain. And we haven't even touched strings. And I need to cover everything in this session. Okay, we're not going to cover everything because functions, they are, yeah, it's another topic on its own, that one. We're just gonna finish up strings and chars. Then tomorrow we do functions and arrays. Arrays are straightforward. Yeah, we can combine the functions, the discussion for functions in tomorrow's class. So we have encoding, right? You need to understand the word encoding, right? Remember what I said, the integer value itself, right? Integer value for each, that represents each character, each letter, it's called a code. So encoding, it means that we're giving it a code or an integer value, hence encoding scheme. If you understand English, you're not going to have any problems in life. That's how I understand things. You know that you can understand a definition if you don't even know what it even means. Basically, you don't know the right, you can understand a word without understanding its definition by just looking at the word. So yeah, try to break down words. For example, line, feed, space, that. There's two words. There's line and feed. Find a way to make that make sense to you. That's how I understand words. So we have this. So we have encoding. So there's two ways to do things. That we have the process of encoding. Then we have the process of decoding, right? So the process of encoding is basically to give a character a code, right, which is an integer value, which is basically the ASCII table or Unicode table. Then to decode is to do vice versa. Basically, when you're given a code, find the char. That's decoding. If you code Java, if you code in Java for a very long time, you'll find out when you start learning to make websites and stuff, there'll be functions that are called encode and decode. Just spoiler alert, you're gonna encounter those functions if you happen to go into deeper into Java, if you happen to do that. So let me explain the process of encoding. The process of encoding is you're given a character, then you find its code, basically its integer value. So for example, 38, right? So the end sign 38. Or you can again make an example of small letter a, right? To decode it, you need to decode it in the small letter a, you need to find its numerical value or its code or its integer value, which is 97, right? Then in order for this 97 to be stored in the computer, it gets translated to binary. I don't speak the language of the computer, so I'm not going to translate 97 to binary. Just know that you're going to have the binary value for 97. Then in the computer, it gets stored as binary. So to be honest, there's no such thing as text files. Yeah, we're gonna touch back on encoding and decoding, especially when you get to binary files, when you're reading from files. So it's going to translate into a binary number. Then to decode, it's vice versa. It's the opposite. So you're starting from this side, and then you go this side, and then you go this side. Hence the words encode, decode. So you're going to start from binary. You take the binary value, you translate it to an integer number. Then you go Google the ASCII table. Don't worry about that. The computer has an ASCII table. Anyway, you can think about it as it is an ASCII table already stored in it. It knows how to decipher it. Not necessarily the computer. I would be lying if I said it. Okay, yeah, it is. Yeah, because I'm thinking about assembly. Yeah, it is. It is an ASCII code, ASCII table. So you don't have to worry about this translation. Then here it will translate it to A. So it looks at the binary value, converts to binary to dec or decimal. Then it looks in the ASCII table for the integer number 97. So if I scroll down here, you'll see what I'm talking about. You see, 97 represents the smaller letter A. So it's going to go to that ASCII table, it checks, oh, 97 is letter A. That's why when you open a document, like a Word document inside Microsoft Word, you can read the words, right? You don't read binary. But when you right click on that file, you realize that it actually stores it in binary. Let me show you a trick, right? Let me teach you all the knowledge that I have, right? So if I right click on this, right, and I open it, this is what we call binary. This is the language of the computer. You see that it's gibberish. But how come when you double click on it and you open it with the right program, it shows you the image? It's this whole process of encoding and decoding. So when you click on the image here, it decodes it so that it's in human readable form. That's why you're able to see it in such a way that you as a human can understand. All thanks to the developers that were hard working for all those years. That's why we're able to have such a luxury and we forget about these details. But under the hood, this is actually how everything works. You encode, basically store when you save the file, it saves it as a binary. If you want to see the binary, you can even a PDF, you can look at this PDF and open it in Notepad. You see that it's in binary. You see, this is weird binary. Abo, Ino, Nag. It looks like the foreign language. That's the language. You see this when the computer says this, it's like, wow, that's my native language. I'm fluent. I understand. It can read everything. But we want it to be in human readable form. That's why we have apps that open specific documents. For example, if I right click this and I open with Adobe, it's not going to show me binary. It's going to decode it. Then now I can see int, L, all these characters. I can read them nicely now. That's the benefits of decoding and encoding, ASCII and Unicode. So yeah, this is something that you really need to understand. And to represent each character or each symbol, we use the char data type. Then we need to talk about strings. So what are strings? Strings is basically a collection of these characters. It's like if you think about it, let me look for it. It's called a what? A name bracelet, right? Let me see images. Let me see. But yeah, you get the whole idea. You see this, yeah, this bracelet over here. If you look at the thing that binds them, that joins them together, right? It's a string. So therefore, it's a string. And if you look at each letter, another word for each of these letters, we call them characters. These characters are on a string. So therefore, it's a string of characters. That's where they got the term string, because they were trying to make a reference to this. I'm assuming, because this is the best example I can give so that you understand why they chose string. But then if you look at these characters, right, they are given positions. So basically, it's actually an array of chars. This would be position S, would be a position 0. This would be a position K, position Y, position L, position, no position L, what am I saying? 0, 1, 2, 3, 4, 5. So this will be at each, it will have its own index or its own position. We call it an index or a position. And a string is not a primitive type. A string is a reference type. How do you know it's a reference type? It starts with the name of the data type starts with an uppercase letter. That's how you know. Because remember, that's how you declare classes. That's how you name classes. You name it with the starting with the capital letter. So that's how I can easily detect whether something is a reference type or a primitive type. Primitive types, just know you cannot call functions. It's not a class. So therefore you don't do spiritual things and try to call functions. With reference type, it's allowed because it's an object. It's basically creating an object. You guys are familiar with objects. So string, you're actually creating a string object, not a string primitive type. So just like in C++, it's also a reference type in C++, but then they don't use the word reference type. You just say it's an object. So I'm going to say string name, and then I'm going to say is equals to Vortex, right? That's the name that I'm going to store. Then this name, what's going to happen, right, is that Java is going to have like this VORTEX. Then each of these letters will be stored at a specific position or index. So Java sees it in this way. You might see it in this way, but under the hood, Java sees it in this way. So this is how you'd create a string variable. Just use the string type. Just remember that it's a capital letter. You capitalize it, capital letter S. Then give the variable a name or the object name. There's two ways. Remember, we talked about strings in past papers. There's two ways to create a string like this, which under the hood, you can imagine it uses the new keyword under the hood. Then there's the other way, which is the more verbose or the more direct or robust way, which is, let's say x is equals to new string. Then you call the actual constructor from the string class. Then you pass in the value of the string. In this case, I'm going to say it's hi. So that's the string I'm storing into X. You see these two lines here. It's exactly the same thing. The only difference is that here you called it explicit, right? You're direct, you put it yourself. And then here you left Java to do it for you. But then under the hood, just know that a string or the string object is basically an array of chars or an array of characters. So to prove this, to show it to you, let's make an example, right? Let's create a string name is equals to Vortex, right? That's the string that I've created. Let's go through each. I want you to listen to the terminology I use. Let's go to each character. So I'm going to use a for each loop. So for at each index, that's the thing. That's what I said. You really need to understand about this. You really need to understand this thing. Remember what I talked about? I said a string is basically an array of chars, right? An array of characters. That means at each index, the data type is a char. That's something very important to understand. So that means that I'm going to say char and then val colon, then put in the collection here or an array. Remember we said that string is an array. It's under the hood. You don't have to worry about that. It's under the hood. Why is it complaining? I honestly don't know why the thing starts complaining. But this should have worked because it's an array. But I guess Java doesn't want. Let's do it this way. Java views this thing as an object, right? So you'd have to call now we're gonna introduce methods. You'd have to call the method that's called to char array. Remember, a string is an object. So you have to say dot to char array. Basically, in this case, treat it as a raw char array. I want the raw char array. I don't want to work with it as an object in the sense of an object. Because remember, this is an object. It creates this object with this value vortex and it creates it on the heap memory. Then it returns a reference or a pointer to that object. Therefore, the name variable or the name object stores an address to that object with the value vortex. So when Java sees this, it's like, oh, char value of an address. That's spiritual things. You want to get in what are you trying to do there? So it just says this question mark. It's like, I don't know what you're trying to do, but all I know is that that's not going to work. That's spiritual. So that's why you'd have to tell it to convert it to a char array so that it treats it as a char array. That means it's going to get one char at a time. Then I'm going to print those chars at a time on their own separate line. Each of these chars is going to be stored into this variable val. So this is what this is what I was teaching C++. This is what Java does, right? It says val and then it initializes it to the character v, and then we're gonna print it here. Then it goes back up. It takes the next char from this array, which is O, and then it reinitializes it to O, and then output O, and then it does that until it reaches the end of the string. That's basically what it does. So I'm gonna print val here, then I'm gonna run it. Then you're gonna see vortex, right? So there's V, O, R, and so forth until X. So it is indeed a char array. That's why there's even a function called to char array, because underneath the hood, this object, it uses a char array or an array of characters. I hope that makes a lot of sense. I think I should end the session now. This is strings, right? The thing is, I cannot possibly, if I try to explain everything in the language, right? We'll end up creating our own programming language. So that's why if you notice even classes, they don't teach you everything. It's a lot. When I say it's a lot, ne, we can take the whole month just discussing the functions inside the string class, a whole month. Of which that's not luxury. That's not the luxury we have. We don't have that time. So that's why I would do, there's something that we call documentation. You're gonna go here and say type Java docs, right? Or Java doc in singular, then space followed by the name of the thing you want to find Java doc for. For example, I want to find Java doc for strings, so string, or vice versa. You can say string Java doc. That's up to you, or Java doc string. Then you press enter. Most likely going to be the first link. 99% of the time is going to be the first link. Then you click here. Then it shows you all the methods. You're going to go to here where it says method summary. This means these are all the methods that are there. Oh, it's called code point in plural. In one word, it's code point. Yeah, code point, meaning the integer value to represent that represents that character. It's called a code point. Yeah, we have all these methods, and if you want more information on it, right, you click there like this, then it's gonna show you how it works. It might sometimes it might show you an example, but then most of the time it won't. But you can just pray for the pray, just pray that it has an example. If it doesn't, then that's when you have to use things like ChatGPT. So we have content equals, all these things. There's a lot here. There's a lot of methods. Like I said, do you see how many methods are here? You can scroll down and see. And you want me to explain every single method? If I was to explain every single method, I would expect you to know every single method. Do you see do you see now where the problem is? Imagine if the lecturer taught you every single function. They would ask all of these functions in the test. And we're just talking about the string class. There's other classes too. So yeah, that's why we just teach you just one or two few things, then the rest you go figure it out. Because you have a computer, right? You have Wi-Fi, right? Put it to good use. Go check the documentation. Then if you wanted to get a char or get a specific character, remember it's like I said, a string is an array of characters, right? To get a specific char at a specific position, right? Remember, it's stored at specific positions. Let's say I want to output X. I can call the method called char at. So you put in the string, then dot to call a method. There's the char at method, which just basically gets the char at that index. At what index? At index 5. So that means this would output X, right? So that means before it outputs V, I should see an X. So before V, there's V. Before V, there's the X. So it does access, it does work. And if you try to go beyond the index, right? Let's say you say index 7. There's no index 7. It returns what I call this is a string, right? In full. At least I understand this thing. I understand Java very well. So it's gonna return an exception called string index out a string is what string index out of bounds exception. This is the exception is going to return. You see how long this name is? You'd have to really understand your Java, how it works. It should be somewhere here. Yeah, index out of bounds exception, right? But then it's string index out of bounds because this is the string class, but it's one and the same thing. So I'll just leave it at here, then you guys can go practice with the rest. So you have code points here, you have everything. So when you see an activity, a question here, right? You have to go here and look at the Java doc. It can't be on, they can't possibly put everything on the slides. Because if they put everything on the slides, that means each slide is going to be at least 200 pages. Each slide. Try reading 200 pages of per slide, and you have 12 slides. That's 200 by 12. Use common sense. We can't possibly teach everything. So I'm going to teach two things, one or two. The rest, go figure it out. It's experiment. So I think I should end it here. I shouldn't explain give you any more information, else I'm gonna bombard you guys. Gonna get confused. So this is Unicode, blah, blah, blah. You can also just go here and say Unicode. And then this is the home page for the Unicode. Then you choose the number, right? You see, there's the number. It's 21A9. That's the number for this symbol. Then there's this symbol. It's 1F, 4A6, the water symbol. Yeah, it's the water symbol. I don't know what you know it as, but for me, it's a water symbol. Then you have a cat here, the smile. You can draw the emojis. The thing is, I forgot. I don't want to lie to you guys. I forgot how to initialize. But just go do research. You guys can ask ChatGPT. You can actually print it. I forgot. It's backslash u something. I forgot the something. Let me say smiley. And then you can, I'm not sure if it's backslash u or /u. I'm not sure. I forgot this thing. It's always like this. No. Oh, it's plus. Oh, it's a u plus. I forgot, but there's a way in Java to represent store the Unicode in a char. I forgot. You guys can go Google that. Totally forgot. My brain. I do a lot of things. So it's 1F639. So 1F639. Then I just forgot whether it's backslash u or u plus like this. I forgot how to initialize it. Go find out how to initialize it. Once you know how to initialize it, then you can just simply print it out. You see, when you see the terminal here, it's going to show an emoji. I can bet you my YouTube channel, it's going to show you an emoji. So yeah, you go test that out. That's your homework. Go figure that out. Me, I forgot. I don't have time to be searching that because it's insignificant. You know, they'll never ask you that. You will never really store Unicode unless if you're making a mobile app. Are we making a mobile app? No. So we don't need to be printing emojis and stuff. That's why I don't really care that much about it. So that's it for today's class. You can just go check this. It's at home.unicode.org. Check it out. You choose the symbol that you want. You look at the number. The U plus it's a prefix to say that this is a Unicode. The actual value is the number starting from after plus. That's the actual Unicode value or the code point. They call it a code point. So yeah, that's it for today. We'll discuss functions tomorrow. So we're gonna discuss functions, which is basically methods. Let me stop recording so that I don't unnecessarily make the video long. So we're gonna start talking about